Continue the topic, that is basic inequalities. Let's solve some further questions. Okay, now these are two different terms, and as we discussed in the previous class, I cannot cross multiply. Let's rewind and revise the topic. If I say a is greater than b, then I cannot multiply the two sides with x and say that an inequality exists, because no inequality exists. If x is greater than 0, if x is a positive number, then I can say that ax would still be greater than bx. But what happens if x is less than 0? If x is less than 0, then the possibility is that there is going to be a negative term. With a negative term, I'll get ax. This will also be a negative term. Bx. This will also be a negative term. And as we just saw, a, that is a term which is greater than b. Since it was greater than b, if I multiply with a negative sign, this term will be greater in magnitude, but because of the negative sign, it will be less than b of x. So the sign of inequality gets reversed. Now we are not sure whether it will be greater than or less than. That is the reason why, if the sign of the term with which the inequality is multiplied is not known, then we can say that we cannot put any inequality in between. Therefore, I cannot cross multiply them. So I'll use the basic conventional approach, that is of subtracting this term from both the sides. Now this will be the final expression. If I have to solve this further, now I can create a common denominator by taking LCM. That is going to be x square minus x multiplied with x square plus x plus 1. So in the numerator, I'll get x square plus x plus 1 minus of x square plus x greater than 0. Now let's observe what happens. I'm going to solve it further. Let's try to solve it over here. Now x square minus x square gets cancelled. X plus x is twice of x plus 1 upon x times x minus 1 multiplied with x square plus x plus 1 is greater than 0. Let's try to analyze the quadratic equation. The quadratic expression is x square plus x plus 1. So now as I say, x square plus x plus 1. Let's try to analyze this quadratic expression. We'll write it as f of x, since it is a function of x. As the values of x vary, the expression's value is also going to vary. So let's try to calculate the discriminant, which will be b square minus 4ac. b over here is 1 plus square minus 4 times a, that is 1, and c, that is 1. So obviously it is coming out as minus 3. It implies that discriminant is less than 0. If discriminant is less than 0, then according to Sridharacharya's method, what do we get? Minus b plus minus root b upon 2a. Now since the under root term is negative, or it will be imaginary, what can we say? They are going to be two unequal but imaginary roots. They are going to be conjugate of each other, obviously. Since they are going to be imaginary, then we can say that according to quadratic equation, either the graph is going to be like this or the graph is going to be like this. Since we observe the coefficient of x square is positive, that means this is not possible for all values of x. This is going to be the final result. That is, the value is always positive. So now I can say that this term is always positive. This is always positive. Now I know the sign of this term because it is always positive. Now I can multiply both sides with it and it will be correct. So if I multiply this on both the sides, this get cancelled over here, and on multiplying this with 0, what do I get? Again a 0. Now let's move further. My question reduces to a simple form. Which is on the board like this. Twice of x plus 1 upon x multiplied with x minus 1 is greater than 0. Now if I multiply and divide by x and x minus 1, what will I get? 2x plus 1 into x minus 1 divided by x square into x minus 1 plus square is greater than 0. Now since the denominator is again a positive term, because they both are expressed in the form of squares, and square of any number is always going to be positive. So now I can multiply both sides with this term, that is x square x minus 1 the whole square. Since these positive terms are multiplied on both sides, what will be the final result? 2x plus 1 into x minus 1 is greater than 0. This will be the final result. But we have to keep in mind that the denominator can become 0. And if it becomes 0, the expression becomes undefined. So we have to remove those particular values of x from the expression in order to make it defined. So I have to write over here, provided that x is not equal to 0 or 1. If x is not equal to 0, if x is not equal to 1, only then can I say this. Because if the value of x becomes 0 or 1, if the value of x becomes 0 over here, the function becomes undefined. If the value of x becomes 1 over here, then 1 minus 1 becomes 0. and 0 in the denominator makes the expression undefined. So you have to keep in mind that the value of x should never become 0 and 1. Now let's move further in this question, which I'll be solving over here. So the expression becomes 2x plus 1 multiplied with x into x minus 1 is greater than 0. Now, as we discussed in the first lecture, in order to solve the inequality, we have to convert it into standard form. The standard form is x minus a. That was the general expression which we solved in the first lecture. So this becomes x plus 1 upon 2 into x minus 1 greater than 0. There will be a 2 which will be taken common outside, but if I divide both the sides by 2, this gets cancelled. 0 upon 2 is also 0. So let's move further. Now I can plot the roots of the quadratic equation. From this expression, I can say the root is going to be minus 1 by 2. From this expression, I can say the root is going to be 0. From this expression, the root is going to be plus 1. Now, as we discussed in the last lecture, the extreme values, that is the values on the right hand side of the largest root, are going to deliver a positive expression, then alternating signs negative, positive and negative. We also discussed that the sign remains unchanged if the root is present inside a power which is even. If there is an even power, the root coming from this factor will not alternate the sign because the square of any number is positive, and that is true for all even powers. So let's not waste the time over that, and let's move forward in this question. As we know, this expression should be greater than 0. That means positive values are going to be taken. If I'm going to include only the positive values, then I can say that x belongs from minus 1 by 2 to 0, or from 1 to infinity. Since there is no equality, what is this? This is strict inequality, which we discussed in the first lecture. Strict inequality, what does that tell us? Strict means it is only going to be greater than 0. That means these values are not going to be included. So I'm going to put open intervals and a union sign in between them. Open intervals and union sign, we have to remember that 0 and 1 should not be present. 0 is not present, 1 is not present. So this is going to be my final answer for this question. I hope you have noted it down. If there are any doubts, I'll like to answer them. Okay, no issue. Let's move forward to the next question. Now let's try to practice this one. This is not much of an inequality, it is more of a concept based question. If I say x squared plus 5 by 3 is less than equal to 0, what is x squared? Square of any number is always a positive term. As you guys may remember, this is the graph of x squared. X squared graphs looks something like this. This is x squared. If I put 1, what will I get? 1. If I put minus 1, I'll again get 1. If I put 2, I'll get 4. If I put minus 2, I'll again get 4. So irrespective of the sign of the input, the output is always positive. So we can say that the range of my function x square belongs from 0 to infinity. That means its output will always be positive. So it means x square is always positive. Since it is always positive, if I add another positive term to it, is it possible for the number to either be 0 or less than 0? No, it is not possible. If I'm adding two positive terms, one of which is greater than 0, then the answer cannot be equal to or less than 0. So by concept, we can obviously say that x belongs to a null set. That is to say, there is no solution. Now the important thing about maths is that no solution can also be a solution. That's why in most of the questions of JEE means you'll observe that there is an option which indicates that there is no solution, because as we see in this question, there is no value of x which will satisfy this, because there is no value of x which, when input over here, would give a number which is negative, since 0 or a positive number added with a positive number can never be less than or equal to 0. So we come to the conclusion that there is no solution to this question. Therefore, x belongs to 5. Let's move forward to the next question. Okay, now this is a similar one which we discussed in the previous lecture. I would like you to solve this one. If there are any doubts, I would like to answer. Okay, let's move forward. By zero product law, we can say that either x minus 3 is equal to 0 and x is equal to 3 is going to be a root of the equation. By zero product law, I'll say that x minus 4 is equal to 0. That implies that x is equal to 4 is going to be my second root. If I have two roots, one value is 3, another value is 4. Extreme values are always going to be positive, as discussed earlier, negative and then positive, since they will be alternating. We are talking about greater than equal to 0. So these two intervals are going to be included. Finally, we can say that x belongs from negative infinity to 3 union 4 to infinity. Infinities पे I'll have open intervals. What about 3 and 4? If we put the values 3 and 4 in the expression, the answer is going to be 0 since they are the roots. But because as the expression says, equality is also included. That is equality is accepted in the inequality. If the values are equal, then also they will satisfy the expression. So x equals 3 and x equals 4 should also be present in my answer set. So I'm going to put closed intervals 3 and 4. Let's move forward to the next question. Now it's a quadratic equation. Let's multiply it with a negative sign in order to make it in a standard form. A standard form of writing any quadratic equation is ax squared plus bx plus c equals 0. Let's try to convert this. I'll get x squared minus 3x plus 4 less than 0. Since this is my quadratic equation, now I have to solve it. Now, can I write it as x squared minus 4x plus x plus 4 less than 0? No, this will be incorrect. We'll have to use the formula in order to solve this. So it's going to be x equals minus b, that is 3, plus minus root of b square, that is going to be 9 minus 4 times a times c, divided by twice of a. Now as we observe that 16 and 9, the difference is of 7. So answer is going to be 3 plus minus under the root 7 with a negative sign. So as we can observe, the answer is always going to be imaginary roots. Since the output is going to be imaginary roots, we know that imaginary roots always exist in a pair conjugate of each other. So there will be two imaginary roots, and as I can say that they are going to be conjugates of each other. Is it possible for an imaginary number to be less than 0? As discussed in the chapter complex number, for complex numbers inequality don't hold any meaning. We cannot say a complex number is greater than another complex number, because complex numbers, unlike real numbers, cannot be compared with another complex number. It is to say that one complex number lies over here, that is a plus iota b. Then there is another complex number c plus iota d lying at some other place. I cannot say that one complex number is greater than, less than, or equal to some other complex number, because there is no comparison. So inequality are meaningless in complex numbers. Let's move forward to this question. As we can say that since it has imaginary roots, so the answer would either be an upward open parabola or downward open parabola. Since inequality has no meaning and it has imaginary roots, that means the graph is never going to cut the real axis. If the graph is never going to cut the real axis, what can I say about it? It will always be greater than the real axis, or it will always be less than the real axis. If we observe the coefficient of x square, it is 1. That means a positive number. If the coefficient of x square is positive, that means downward open parabola is not possible. Only upward open parabola exists. In the case of upward open parabola, we can simply say that all the values are going to be positive. That means all the values of my f of x would be greater than 0. They won't be even equal to 0, because if they become equal to 0, then the quadratic expression would have had two equal roots. But since we say that there are complex roots, so there is no value of f of x which will be below the real axis. That means all the values are greater than 0. So it is not possible for the expression to be less than 0, which implies again x belongs to 5. Let's move forward to the next question. Okay, now I have another expression which says x square minus 4x minus 8 less than equal to 0. Let's observe the discriminant. That is going to be b square minus 4ac. If I substitute it, I'll get minus 4 the whole square minus 4 into a into c. That is minus 8. This is 16 plus 32. That is going to be 48. That means I can solve this to get two roots of the expression. The two roots are going to be x equals to minus of b, that is minus 4, plus minus under root of discriminant, which is going to be 48, divided by twice of a, that is 1. This is calculated by the Sridhar Acharya's formula, b square minus 4ac. We substituted minus 4 over here, minus 4 times a, and then c, that is minus 8. So it is 16, minus minus becomes plus, and 32. So I copied the number 48 over here. I'll get 4 plus minus 48 can be written as 16 threes are, so 4 root 3 upon 2 is 2 plus minus 2 root 3. These are going to be the two roots of the expression, and if I try to plot this on the number line, I'll get two values. One value will be 2 plus 2 root 3, another value will be 2 minus 2 root 3. Positive, negative, positive. Negative values are included, so the final answer will be 2 minus 2 root 3 to 2 plus 2 root 3. And since there is an equality sign, so I will have to put closed interval for the answer. Let's move forward to the next question. Okay, now it is a simple one. Since the numerator is written in the form of x minus 5 divided by x minus 8, which is less than equal to 0, so I can write it as x minus 5 into x minus 8 divided by x minus 8 ka whole square less than equal to 0. So finally I can say that this is the positive number, so both the sides can be multiplied with it. But we have to remember, for it to be defined, x should not be equal to 8. If x is not equal to 8, only then I can say that x minus 5 into x minus 8 is less than equal to 0. Now I have two roots of the equation. One is 5 and the other is 8. This is going to be positive, negative and positive. The expression should be less than equal to 0, that is the negative values. So finally I'll say x belongs to the interval 5 to 8. Since there is equality, so I can input the roots, because for the value of roots the expression gives me 0. I will have to put closed interval from 5 to 8, but as we just saw that 8 is not possible, so I have to exclude 8 from the interval. So my final answer becomes 5 to 8. 5 is included, 8 is not included. And as we discussed in the beginning of this lecture series, that a number just less than a particular number cannot be found. So we cannot find the maximum value of x. If the question had asked, what is the minimum value that x can take? Obviously the answer was 5, because 5 is the minimum value. But if the question says, what is the maximum value that expression can take? Then the answer is going to be does not exist, because we cannot find the value just less than 8. 8 is not included, but the value just less than 8 is included. Someone may say 7.9, but what about 7.99? Because that is also included in the expression. So finally we say that the value which is maximum, sorry, the maximum value of x satisfying that expression does not exist, because 7.99 if is present, then 7.999 is also present. And what about 7.5 times 9? This is also going to be present. What if someone says another number larger than this, which is 7.6 times 9? This number is also going to be present. So a number just less than 8 cannot be found, because no matter how many nines you put after 7, I'll add one more 9 and that number would be closer than 8, closer to 8 than the previous number. So finally we understand why f maximum is not defined. Now let's move forward and talk about modulus inequalities. Modulus, as most of you might have studied, comes from the word mod operator. If I'm talking 7, you'll get 7. Modulus of negative 7 is going to be plus 7. No matter what you input, the output is going to be 7. If I input 5, the output will be 5. But if I input minus 5, the output would still be 5. If I input 2.3, the output would be 2.3. But if I input negative 2.3, the output would be still 2.3. That means the negative has no meaning for mod. The output would always be positive. Let's try to understand what is happening by the help of a graph. And I'll be using an expression set y is equal to mod x. So mod x is equal to plus x if x is greater than 0. If the input is greater than 0, that is to say the value of x lies on this side of the origin, that is on right hand side. If I input a positive value, the output will be positive. So I have to say that the equation of the line would be y equals to x. This is what you have studied in class 10. Y equals to x is a straight line. You input 1, you will get 1. You input 2, you will get 2. You input 3, you will get 3. That is what modulus is doing for positive values. But what happens if x is less than 0? Then I should get negative x. That is to say, if I input minus 7, then I should get minus of minus 7. So the output will be plus 7. If my x is equal to minus 8, then mod of minus 8 will be minus of minus 8. That is going to be plus 8. That is the reason why we say that y is equal to minus x when x is less than 0. If I'm talking about x is less than 0, which is this interval, then I can say the equation is y equals to minus x. So this will be the equation of the curve y equals to minus x. So now we get two equations. One is y equals to plus x when x is positive. One is y equals to minus x when x is less than 0. For these two equations, we get the final graph. This is the graph of modulus inequality or modulus expression. Let's try to understand the observations from this. If someone says that mod of x is greater than 3, what does that mean? That means the output of this modulus function is greater than 3. That means these are the possible values. If these are the possible values, then I can say that the input was greater than 3 or the input was less than minus 3. So we have to say that either x was less than minus 3 or x was greater than 3. The common point of confusion over here is that some students confuse union and intersection over here. As we observe, a value greater than 3 and less than minus 3 cannot exist at the same point. Either it will be greater than 3 or it will be less than 3. So we have to make sure that if I'm talking about modulus x greater than 3, then I'm going to get two conditions. If it is greater than 3, either x will be greater than 3 or x will be less than minus 3. Either of them. If x is lying in this interval, then also it's correct. If x is lying in this interval, then also it's correct. Let's talk about second condition. If I say that x mod x is less than 3. If mod x is less than 3, then this is going to be the output. If this is the output, then what about the values of x? Either they are less than 3 or they are greater than minus 3. So as to say, x should lie between minus 3 and 3. Now we are not talking about union, because a number which is greater than minus 3 at the same point of time should be less than 3 for mod of x to be less than 3. So we come to the conclusion, when we are talking about less than sign, are we considering? Intersection. That is the common points only. And when we were talking about mod x greater than 3, what were we talking about? Union of two intervals. Because a value satisfies this condition if it is greater than 3 or when it is less than minus 3. If I input minus 5, I'll get 5 which is greater than 3. So the point of importance is, when I'm talking about less than, we have to remember intersection. When I'm talking about greater than, we have to remember union. Let's move forward and try to solve a question. If I say mod x is less than a, this is going to be the graph of mod x. This is going to be my point A. Mod of x is less than a. On this axis I am writing mod x, on this axis I am writing x. Mod x is less than a. If it is less than a, then we have to say that for this output, the input should have been between these two values. If the input had to be between these two values, either from minus a or to a, so x should lie between minus a and a. But since there is no equality, we don't have to put the equality sign over here, and a final answer would look like this: x lies between minus a to a, and this is the expression. Let's change the question and discuss it in another format. Let's change it to greater than. If mod x is greater than a, then what will happen to the answer set? This is going to be the graph of mod x. Agar mod x की value is greater than a, then I can say that this is going to be the output. When is that output possible? Only if x is greater than a or if x is less than minus a. So I can say that either x is less than minus a or x is greater than a. So now we have two conditions, either this or this. Unlike the previous case when we had intersection, now we are taking union of first interval and union of second interval. These two are going to be the final answer sets. Let's move forward to the next question, which says 3x plus 8 less than equal to 2. Let's try to remember it by using the graph. This is my expression, which is f of x. Now f of x should be less than equal to 2. If it has to be less than equal to 2, that means the value should lie between minus 2 से 2 तक. If the value is lying between minus 2 to 2, what does that mean? 3x plus 8 should be greater than minus 2, and because it is less than equal to 2, that means this is the output. So my input should be between minus 2 and 2. So it should be either greater than minus 2 or less than 2. So the other point will be 3x plus 8 is less than 2. So I can say that 3x minus 8, minus 2 minus 8 becomes minus 10. So x is greater than minus 10 upon 3. And on this side, I'll subtract 8. So I'll get 3x less than 2 minus 8 is minus 6. X is less than minus 2. Let me just recheck. It's minus 8 minus 10. Right. So x will be greater than minus 10 by 3 and less than minus 2. This is going to be minus 3.33 something. So finally the answer is going to be between these two intervals. So I'll say that x belongs from minus 10 by 3 to minus 2. And since we are taking equality, so equality would also be present wherever we were using an equality, and finally we'll put the closed interval over here. I hope that's clear. Let's move forward to the next question. So this is mod of this greater than 3. This is the modulus operator. and the value is 3. If the output has to be greater than 3, what does that mean? The input should be greater than 3, or it should be less than minus 3. Mod of this expression is greater than 3 for all values greater than 3 or for all values less than minus 3. So x upon x minus 1 should be either greater than 3 or x upon x minus 1 should be less than minus 3. If I have to solve this, I'll write it as x upon x minus 1 minus 3 greater than 0. So finally it becomes x minus 3 times of x minus 1 divided by x minus 1 greater than 0. So it will be x minus 3x plus 3 upon x minus 1 greater than 0. X minus 3x is minus 2x plus 3 upon x minus 1 greater than 0. So it's going to be minus 2 common, x minus 3 by 2 upon x minus 1 greater than 0. Finally, I can say it as x minus 3 by 2 whole upon x minus 1, since it's a negative term. So the inequality will get reversed as we had discussed earlier. Now let's try to plot this on the number line. What are going to be the two roots? The two roots are going to be 3 by 2 and 1. So I'm going to put 1 over here and 3 by 2 over here. Positive, negative, positive. We have to take the negative term, that is with this interval, which is going to be from 1 to 3 by 2. There is no sign of equality over here. So I'll put open interval 1 to 3 by 2. So my final answer from this becomes from 1 to 3 by 2 open intervals. I have represented that on the number line. Now let's try to solve the second part of the same question. Second part says x upon x minus 1 minus plus 3 should be less than 0. So it becomes x plus 3 times x minus 1 upon x minus 1 less than 0. So it's going to be x plus 3x is 4x. Just a second, x upon x minus 1 plus 3 less than 0. So 3x, okay, right. 4x minus 3 upon x minus 1 less than 0. So if I take 4 common, I'll get x minus 3 by 4 divided by x minus 1 less than 0. What are going to be the two roots? The two roots are going to be 1 and 3 by 4. The two roots are 1 and 3 by 4, and as we know it's less than 0, so the values in between them would be included in the answer. If I plot this, it is going, 3 by 4 is going to lie on the left hand side and 1 is going to lie on the right hand side. This will be 3 by 4, this will be 1. Since 3 by 4 is 0.75, so it's less than 1. So finally I'll write 3 by 4 over here, and the answer is going to be this. So I can write x belongs from 3 by 4 to 3 by 2 open intervals except 1. Other way of writing the same thing is the expression is going to be from 3 by 4 to 1 union 1 to 3 by 2. They both represent the same thing, that is the interval from 3 by 4 to 3 by 2 excluding the extremities and also excluding 1. I hope that's clear. So thank you for today's session.